All right, algebra students. Well, I'm out this week. I put together this lesson video for you guys here. This says 2.2 up there, but we're not really doing 2.2. We're actually going to do 2.4 today. All right, we'll fix that, 2.4. Okay, this is going to be our last lesson here in Unit 2. All right, and so far what you guys have done in 2.2 and 2.3, you guys were factoring these types of trinomials here, working those problems backwards. You guys had a couple warm-up problems to do for those too. All right, we're going to do the same thing kind of today. We're going to take a look at working some other types of problems backwards. But first I want to take a look at what we did in Unit 1, because I've been telling you guys Unit 2 is completely backwards. It's going in reverse of what we did in Unit 1. All right, so take a look at these two problems. Something we did in Unit 1 was a problem like this here. We got x plus 2 to the power of 2, and we multiplied that problem together. And because we got this power of 2 here, this is what it ended up looking like. It looked like x plus 2 times another x plus 2 like that. All right, and then what we did was our classic foiling that we've been doing here for a while. All right, we foiled and we multiplied those together. And when we do that, here's what we would end up with. We would get x to the power of 2 plus 2x when we multiply x times 2 plus another 2x for those, plus 2 times 2 would get us 4. All right, then we could combine our like terms in the middle and we would get x squared plus 4x plus 4. All right, so that's something we did in Unit 1. We multiplied problems like this to get that answer right there. Okay, what we're doing today is just going backwards. We're going to be given the answer and we're going to go backwards to figure out what did it look like before all the multiplying took place. Okay, so that's one type we're going to work with. Another type we're going to work with was these problems here, where they almost looked identical, but one was addition and the other was subtraction. Okay, so if we take a look at how this would foil, like we did in Unit 1, if we multiply it, we would get x squared minus 3x, and then right here in the middle, we get plus 3x. And then at the end, we get minus 9. Okay, and there's something unique that happens with these type of problems. When one is addition, one is subtraction, and they look pretty much identical, these like terms in the middle end up canceling out, and we end up with x squared minus 9, and that was our answer to this problem here being multiplied. All right, that was Unit 1. Now we're going backwards. We're going to take an answer like this, go backwards, and figure out what did it look like before all the foiling took place. Okay, so that's the two types we're working with today, and that's our last lesson here in Unit 2. Okay, so let's take a look at our first one we got. We're going to be looking at these guys right here first. Okay, well, first we got to take a look at, before we do that, this is important. We got to look at numbers that are perfect squares. Okay, so there's numbers in the world out there that are called perfect squares. An example of one of them is 16. Okay, and I want you to think about why 16 would be considered a perfect square. Another one, 25. Another one, 36. Okay. Why they're perfect squares is because each of them is the product of two of the same exact numbers being multiplied. All right. Those numbers we end up calling perfect squares when that happens. Not all numbers are like that. Okay. And we could also actually take any one of them, take the square root of them, and it ends up equaling a whole number. All right, so any of these, we could do that, and it ends up being a whole number. So that would be considered a perfect square. We're going to do some of this here today, so that's why we reviewed that, so you can see what that is. All right, there's lots of perfect square numbers out there. There's 3 examples. So with that in mind, let's take a look at what we have first. So This type of trinomial we have here, this x squared plus 10x plus 25, is actually called a perfect square trinomial. All right, and I'll show you why it is. So we're going to factor it to see what it looked like before, and we'll take a look at why it's a perfect square trinomial. Now, I have some good news for you guys. All the way till the end of the chapter, I saved the good news. We got some shortcuts that are going to help us out. When you're factoring a perfect square trinomial, there's some shortcuts, all right? I want you to take the first term and the last term, and you're going to do the square root of the first term and last term. Okay, so if I take the square root of the last term, this is just a plain number, so that's easy. That's 5. Okay, and then anytime you take the square root of a variable with an exponent, you're simply just going to divide the exponent by 2. Okay, so this exponent of 2 divided by 2 would simply just be x, or x1. All right, so that's the first thing we do when we work with a perfect square trinomials. We're going to take the square root of this and the front and the end, the last. All right, then we check if we multiply these two together, that's going to end up giving us 5x. And take a look, it is exactly half of that term in the middle. It is 5x is exactly half of 10x. Okay, so there's our two checks. So that worked out, that worked out. All right, so here with those two steps that we did, we can figure out what this problem looked like before it got FOILed. And here's what it looked like. We're going to take this and this, the addition sign in the middle there in front of that 10, and here's what happened. X plus 5 got multiplied by x plus 5. All right, those two binomials were FOILed together to make that answer right there. All right, another way we could write them is x plus 5 to the power of 2, or x plus 5 squared. All right, and that's where we get that term perfect square trinomial, because it comes from two of the exact same binomials getting multiplied together. All right, let's take a look at a few more examples, and we'll go through these two steps again so that we can factor these perfect square trinomials. Okay, so here's another one. We're told to factor this right here, x squared plus 12x plus 36. Okay, so first step, you're going to take the square root of both the first and the last. All right, so when you do that, x squared is going to be x. All right, we're simply just dividing those exponents by 2. 36, we worked that out previously on the screen. That would be 6. Okay, so there's our first check, is that we can take the square root of the first and the last. Second, we're going to multiply them together. We're going to get 6x, and it needs to be exactly half of that term in the middle. Okay, so since it is, that part checks out. All right, so we're going to take our two terms that we came up with right here and whatever sign is there in the middle, and we're going to put it together, and it ended up being x plus 6 times x plus 6, or you could write it as x plus 6 to the power of 2. Okay, so that's what got multiplied together to give us that trinomial that we ended up with. Okay, so there's how we work those backwards. All right, let's take a look at some other ones here. So we're going to take the square root of the first term and the last term. The first term is going to give us x. The last term over here, square root of 100, is going to be 10. Okay, there's our first check. Second, multiply them together. We're going to end up with 10x. And we want to make sure that that is exactly half of the middle term, and it is. All right, so now we're going to group up this term and this term using whatever operation we have there in front of the middle. Okay, and we're going to put that together. So this ended up being, what got multiplied together was x minus 10 times another x minus 10, or you can simply write it as x minus 10 to the power of 2. All right, this got FOILed. And if we do the foiling, it would end up giving us that answer over there, a perfect square trinomial. All right, a few more. We'll practice some other ones. We'll change some numbers on us here. Okay, so take a look. Now we got a number out here in front. Still the same thing. See if you can take the square root of the first and the last. All right, so if I take the square root of the first, my 4 is going to work out to a 2, and my x2 is going to work out to an x. Okay, and then over here on this side, 25 is going to work out to 5. All right, there's my first check. They worked out to, we could take the square root of both first and last. Second check, we're going to multiply them together, and we end up with 10x, and we check to see if it is exactly half of the middle. Okay, it is. So now we know what got multiplied together. We're going to group up this term and the operation in front of the middle, and we're going to end up with 2x plus 5, and we can just write it with a power of 2 right there, because we know it is 2 of these that got multiplied together. All right, let's do this last one here. We'll take the square root of the first and the last. All right, we have our 9, so the square root of 9 is going to be 3. x2 is going to be x. Okay, and then 64 is going to end up being 8. All right, so there's our first check. We can square root both the first and last. All right, second check is we need to see if we multiply them, is it going to be half of what we have in the middle? All right, and it is. It's going to work out. Okay, so now we can group these together to make our binomial. We're going to take this term and this one and the operation in front of the middle. So it ended up looking like this. This is what got multiplied together. X minus 8 to the power of 2 happened, and it made that answer there. All right. Not as complicated as what we were doing the days before, is it? All right, it's a lot simpler when we got these perfect square trinomials. Okay, so let's take a look at what else we're going to do here with those. Now what we want to do is we have 3 different problems here, and we want to identify if they actually are perfect square trinomials or not. Okay, if they are, we're going to factor them, just like we were doing on the previous screen. Okay, if not, we're not going to do anything with it. Okay, so for it to be a perfect square trinomial, our first check is to see if we can take the square root of the first and last term. All right, the first one works out. 36 would give us 6, and x2 would be x. Okay, the problem is this right here, the 14. All right, the 14 is not going to work out to be a perfect number. If you take the square root of that in your calculator, is not going to be a whole number. So this is not going to work out. So that first example we have is, we're just going to put a no there because it's not a perfect square trinomial. All right, it doesn't meet those conditions like we were working on the previous screen. Okay, so we're not going to factor that one. We're just going to say no, it is not one of these up here. Okay, let's take a look at the rest of them. So we need to check if we can take the square root of the first and last term. All right, it looks like we can for the first term. x2 would be x, and 4 works out to be 2. All right, then there's our first check. Second check, can you multiply them together, and do they make half of the middle? All right, it absolutely does. There's our second check. So this one is, yes, a perfect square trinomial. So now let's put our terms together and our operation in front of the middle to show what got multiplied together. All right, so there we go. We factored it. X plus 2 got multiplied with another x plus 2 to make that answer. Okay, last one. Let's test this one if it's a perfect square trinomial or not. We're going to take the square root of the first term. So that's going to work out. That looks like it's going to be 2x. We're going to take the square root of the last term, and 49 is also a perfect square. That's going to work out to 7. All right, now we just need to check, can we multiply them together to end up making half of the middle? And this one No, it's not gonna work out. All right, 14 is obviously not half of 20, so this one is not going to be a perfect square trinomial. So we can put down a no. We're not going to factor it. We're just going to simply state it as not one of those. All right. Try this one on your own. See what you come up with. See if that is a perfect square trinomial or not. And if it is, factor it. If it's not, you can simply just put a no and be ready to think of a reason on why it is not. All right, we'll pause the video, try that on your own, and then we'll see what you get for an answer. Okay, let's take a look and see what this ended up working out to be. All right, this one is no, it is not a perfect square trinomial. Okay, we did get a perfect, we were able to take the square root of our first and last term. That worked out, but it is not half of the middle there, so they would end up being a no. All right, so hopefully that one worked out for you guys. Let's take a look at our other types of problems we're going to do. Okay, so we're going to look at these. This is a binomial because it's just made up of two terms. And this special one here is called a difference of two squares. Okay, so difference means subtraction. So take a look. We have this subtraction right here, and it's called the difference of two squares. Okay, and we can factor this. This is what we're going to factor it. So take a look at what we're going to do. We're going to kind of do something similar to what we were just doing on the previous ones to figure out how to factor it. We're going to take the square root of the first and the last. Well, I guess there's only two of them. So we're going to take the square root of each of them. Okay, so this would end up being x, and this would end up being 5. And as long as we can take the square root of both of them, we can figure out what got us this answer right here. And here's what happened. Kind of like we worked in the very beginning of this lesson 2.4. We're going to take both of these, put them together. One binomial is going to be x plus 5, and the other binomial is going to be x minus 5. Okay, so they're almost identical, but one is addition, the other one is subtraction. Okay, if you FOILed it, if you went through your FOIL steps, it worked it out, you would end up getting this right here. You would get x squared minus 5x plus 5x minus 25. All right, and those terms would cancel out at the middle, and you're left with x squared minus 25. All right, which is exactly what we had up there. Okay, so this type of problem here, if you can take the square root of both of those, it ends up being this difference of two squares, we call it, and we know it's going to look like that right there. All right, let's try a few more examples and see what we got. Okay, so we want to identify if these are a difference of two squares or not, if it's this special type of binomial. So let's check. Can we take the square root of both of those? All right, x2 would be x, 81 would be 9. We can, so that checks out. So now we just need to put them together, make our two binomials. We have x plus 9, and we have x minus 9. All right, that is what got FOILed to make that answer over there. All right, check out our second one. We want to see if we can take the square root of both of them. We can take the square root of x2. We'll check if we could do 40. x2 would be x. 40 doesn't work out to be a perfect whole number. All right, if you put that in your calculator, you'd end up getting a decimal number. So that is not going to work. So this one is not one of those special type of binomials where something like these two got multiplied together. Okay, so we're not going to try and factor it. We're just going to simply put no, that it's not going to be one of those. All right, check out our last one here. We got 64x squared and we have 16. We'll see if we can take the square root of those. 64 is going to come out to 8, and x to the power of 2 is x. 16 would come out to 4. They both work out, so then we'll just put them together. So we got 8x plus 4 times 8x minus 4. All right, that's what got FOILed together to make that answer there. All right, so we simply worked it backwards, figured out what it looked like before it got multiplied. Okay, let's take a look at a few more. Some of them can look kind of strange. We'll take a look at some strange ones here. Ooh, take a look at this one. 9x to the power of 6 and 25x2. As long as we can take the square root of both of those, then we're okay. All right, and for your exponents, you're just dividing those by 2. Okay, if you can do that, then it's going to work. All right, so this here is going to be 3x to the 3, okay, because I'm just dividing that 6 by 2. And this over here is going to be 5x. All right, so they worked out. We could take the square root of both of them. So here's what happened. It was 3x to the 3 plus 5x, and it got multiplied by 3x to the 3 minus 5x. Okay, there's our two binomials that make that answer there. All right, if you actually did some foiling with them, I'm not going to do that up here, but if you did, you would end up with that answer there. All right, you could check it if you want to, if you don't have anything else better to do. Okay, last one, let's take a look, see if this one's going to work. Okay, so we'll see if we can take the square root of both of them. Okay, so this would get us 9x, and you're going to divide that 8 by 2, so 9x4. Oh, we got a y over here, geez. Okay, so then this one's going to be 5y, and we can divide that 4 by 2, and it ends up being 5y2. Okay, it worked. We were able to take and square root both of those. So this is what happened. We had 9x4 plus 5y2 multiplied by the same thing except minus 9x4 minus 5. Let's fix that y. There we go. Okay, that's what got FOILed together to give us that answer over there. All right. I'm going to have you guys try one. Check this one out. See if this is actually a difference of two squares, if it's that special type of binomial. If it is, factor it. All right. If it's not, you don't have to do anything. But if it is going to work out, go ahead and factor it, and we'll see what you guys come up with for that. All right. Let's take a look and see what this would work out to. Okay, so we can take the square root of both of them. So we get 3x and 4. So then we put it together. We got 3x plus 4 and 3x minus 4. All right, so it does actually factor out. All right, there's your 2-4 lesson, you guys, and that is your end of Unit 2. Here's what I got for you guys to work on today here. So you got 2.4.2 checkup. So get that done before class gets out. And then what I'm going to have you guys do, there's a card activity. You're going to practice working those trinomials, factoring those trinomials from 2, 3, 2, 2, and 2, 3. And you don't have any homework today, okay? So that should make you happy, all right? So get those two things accomplished today. Tomorrow, you guys are going to have a practice test, a review over Unit 2, and then your test the following day. All right, so if you got some questions, feel free to reach out. All right, thanks for watching.